Hi, thanks for joining me. Today we're going to be computing a really interesting integral, and that is the integral from 0 to infinity of sine of x divided by x squared multiplied by x minus sine x dx. Now, if you gave this integral perhaps to an engineer, they might look at this and go, well, sine of x is basically equal to x, so x minus sine of x, this guy here is 0, so we've got something times 0, so we're just integrating 0, so all in all, this is 0. However, that's obviously not true because, well, you can't just say sine of x is approximately equal to x, so this whole thing here is approximately equal to 0, so we're integrating something which is approximately 0, so we're going to get something which is 0. Of course, that is bizarre. However, what's really cool about this is we can actually show that this integral here is in fact 0. So your engineer friend could get quite lucky in this case if they were to just approximate and write sine of x equals x. Anyway, let's get to proving that this integral here is 0. Okay, so we want to show that this integral here is 0, and the way we're going to do that firstly is by expanding this bracket here. So this is equal to the integral from 0 to infinity of x times sine x over x squared, but of course we've got an x on the top and an x on the bottom, so we can cancel those, so we get the integral from 0 to infinity of sine of x over x minus sine of x times sine of x is sine squared x over x squared, like so. So this is what we have, and we want to show that this thing here is 0. Well, what we can do is actually just use the linearity of the integral, or to write this thing here is just the integral from 0 to infinity of sine of x over x dx minus the integral from 0 to infinity of sine squared of x all over x squared dx. Okay, so just kind of by writing this as one integral minus the other. Okay, so we want to show that this thing here is 0, and I guess one way we can do that is by showing that this integral here, the integral from 0 to infinity of sine squared x all over x squared dx, is the exact same thing as this guy here, so they cancel one another out. So that's exactly what we're going to be doing, showing that this integral equals this integral, and then that will show that this integral here is 0. Okay, so as I said, we want to show that the integral from 0 to infinity of sine squared x over x squared dx is equal to the integral from 0 to infinity of sine of x over x dx. And now, in fact, you might ask yourself what this integral equals, and in fact, it equals pi over 2. And this is something I proved in a video I made quite a while ago, in fact over a year ago. So I'll leave a link to that video in the description below if you've not seen that result before. But for this video we don't actually need to know that it's pi over 2, we just need to show that this thing equals this thing. But if you want to see how this guy equals pi over 2, check out the video in the link in the description. Anyway, we want to show this guy equals this guy. What we're going to do is some integration by parts, which is hopefully the most obvious thing to do if you want to show this thing equals this thing. So let's start with this thing here. What thing are we going to integrate? Well, if we write this as sine squared x times 1 over x squared, the thing we want to integrate is the 1 over x squared. So we're going to have u equals sine squared x. So that means that du is equal to 2 sine x cos x dx, and then dv we're going to have equal to 1 over x squared dx, which implies that v is equal to minus 1 over x, or not dx, just minus 1 over x. Okay, so to do integration by parts, this guy here is equal to now uv, so this guy times this guy, so minus sine squared x all over x from infinity to 0, then minus the integral of v du. So minus and the minus there will cancel, so we just got plus the integral from 0 to infinity of this guy over this times this guy. So 2 sine x cos x, which we know is just sine of 2x by our double angle formula, divided by x dx. So this integral here, by integration by parts, is equal to this guy here. Well, let's deal with this thing in the square brackets first. When we plug in infinity, well, the bottom here is going to be 1 over infinity, so that's going to make this whole thing go to 0, because notice that sine squared x is always between minus 1 and 1. So this thing here is going to go 0, that's cool. And what about when we plug in x equals 0? Well, we notice we have a 0 over 0 situation, so that's not ideal. But if we just have a think about this, this top here is a sine of x over x times sine of x, essentially. And we know that sine of x over x tends to 1 as x tends to 0. So then we've got something that tends to 1 multiplying by something that tends to 0, namely sine of 0. So this, all in all, is going to tend to 0. So we've got something that's 0 minus 0, so very nicely we can just ignore this square bracket here. It's all just 0. So this integral here is simply the integral from 0 to infinity of sine of 2x over x dx. But what we want to show that it's equal to is the integral from 0 to infinity of sine of x over x dx. So hopefully the most obvious thing to do is just do a u substitution now. So let u equal to x. So of course that gives that du is equal to 2 dx. And then this integral here just becomes the integral from, well, when x is 0, u is just going to be 2 times 0, which is 0. And when x is infinity, u is 2 times infinity, which is still infinity. So we get the integral from 0 to infinity. Sine of 2x now is just sine of u. And divided by x, but x is just u over 2. So we get a half u. But then notice that dx is just a half du. So this is just a half du. And then we've got, essentially on the denominator, we've got 2 times a half, and that cancels very nicely. So we've just got the integral from 0 to infinity of sine of u over u du, which is the exact same thing as the integral from 0 to infinity of sine of x over x dx. And we have shown that this integral here does indeed equal that integral there. So the integral we started with, the integral from 0 to infinity of sine of x over x squared multiplied by x minus sine of x, that guy there is indeed equal to 0, which I think is pretty cool because, as I said, the engineer would approximate x equals sine x, so, sorry, sine x equals x, so that you can cancel out. So you've got the integral from 0 to infinity of 0, and that would be 0, but of course that's not legitimate, it's not rigorous. But in fact, if you do the rigorous maths behind it, it does indeed equal 0. Anyway, I hope you have enjoyed and you've managed to follow along. Thank you for watching. I'll catch you in the next one. Have a great day.